Well, hey there, kiddos. Welcome to your video over solving inequalities. The notes that I have here, every problem on here is on your notes, but we're not going to do every problem that is on the page that you have. So I have kept the numbers so you can keep up with which ones we do. If I didn't do it, you don't have to do it. It's just there for extra practice should you need it. So solving an inequality is a lot like solving an equation. The steps are exactly the same except for one special rule. And the one special rule is if you multiply or divide by a negative number, then you have to flip the symbol. So you have to turn the symbol around. We'll get to that. Hopefully you'll see one of those as we go through this. But remember that when you multiply or divide by a negative, the symbol has to flip and turn the other direction. So question number 1 here, it's an inequality that has variables on both sides. And so just like we did when we were solving equations, we want to move the smaller variable with the bigger variable. So the smaller one is this 3.5x, and I'm going to cancel it by subtracting 3.5x from both sides. And so what that leaves me with is 2.5x minus 1 is less than or equal to 4. And so then I want to get all of my constants or my numbers over to the other side, so away from my variable. So I want to get rid of this minus 1 by adding 1 to both sides. So I have 2.5x is less than or equal to 5. And then I'm going to divide both sides by 2.5 to get x by itself. And so you get x is less than or equal to 2. And so what this tells me, this statement, is that x doesn't just equal 2, it's also any number less than 2. So 2 is a solution, so is 1, so is 0, so is -1, and so on and so on. So as long as it is less than or equal to 2, then it is a solution to this inequality. So look at number 2. Number 2, we saw something similar to this when we solved equations because we had the variables on both sides that each cancel out. So I've got an x and an x, and when I subtract x from both sides, they're going to cancel. When you have an inequality that this happens with, you have to really look at your statement that is left over to see if it's true or not. So if my x's completely cancel, I'm left with 5 is greater than or equal to 3. Well, so you have to ask yourself, is 5 greater than 3? Well, yes, it is. So this checks out. It's a true statement, which means this inequality has infinite solutions. If I had solved this problem and my variables had canceled out and what was left was not a true statement, that's when you have no solution. True statement, infinite. False statement, no solution. So we're going to skip down here to question number 5. So I've got distribution on both sides of the inequality this time. So I'm going to have to distribute this 5 to this entire left side, and then I'm going to have to distribute this 3 to everything on the right side. I've got to clean up my inequality first. So I'm going to distribute 5 times 4 is 20. 5 times x is 5x. It's less than or equal to, and then on the other side, 3 times 2 is 6, and 3 times x is 3x. So I've cleaned it up, I've gotten rid of parentheses. Now I'm going to get my variables together on the same side. 3x is the smaller one, so I'm going to subtract that from both sides. Also, when it comes to solving inequalities, I generally like to have my variable on the left-hand side. It's okay if it ends up on the right, but I usually prefer it on the left. So then I have 20 plus 2x is less than or equal to 6. And so I got to get the 2x by itself, so I'm going to get rid of my 20 by subtracting. And so I have 2x is less than or equal to -14. I'm going to divide both sides by 2. And so my final answer is x is less than or equal to -7. I didn't flip my sign on this one because the number I divided by down here in the denominator was positive. I know that there's a negative in the problem, but it's only if the number you're dividing by, the one that ends up in the denominator. If it's negative, then you flip. All right, number 6. It has distribution as well, so I'm going to have to distribute this -1/3 to everything. And it's okay, we're just multiplying, so -1/3 times n is just -1/3 n. That's the easy one. And then when I do -1/3 times 8, I'm going to do -1 times 8 becomes -8, and then over 3, because that's the denominator. Then I got to bring down this plus 1/3 n is greater than or equal to 1 minus n. And so this looks really scary because you got all these fractions, but look over here on the left-hand side. I've got negative 1/3 and a positive 1/3. These are going to cancel each other out. They don't even matter anymore. So what I have left is negative 8/3 is less than or equal to 1 minus n. Well, I want to get this n by itself, so I got to get rid of my 1, so I'm going to subtract 1 from both sides. When I do that, I get negative 11/3 is less than or equal to, and this is a negative n. Well, so that's really the same as having a negative 1n, so I'm going to have to divide both sides by a negative 1. And so what ends up happening is my sign's going to flip, and my symbol's going to change here. So I'm going to end up with, let me make my page bigger. All that doesn't help. I am going to end up with 11/3 because it made it positive when I divided by the negative. My symbol changes, less than or greater than or equal to n now. So this is my final answer. This time my inequality, let me make this bigger. When I have it written down like this, my inequality symbol is now backwards because my variable happens to be on the right, so you have to read this backwards. So it says 11/3 is greater than or equal to n. That means n is less than or equal to 11/3. It's backwards. That's why I like to have it written on the left, because then it's clear as day what the answer is. But if you want to turn this around, you turn everything around, the n, the symbol, and then the number. This means the same thing as this. It's just written the other way. So if you rewrite it to put the variable on the left, you have to turn everything around. Okay, so now we have an error problem. You were supposed to describe and correct it. So we have to decide what happened, what went wrong, and then we have to fix it. So here's the inequality. We have x divided by 4 plus 6 is greater than or equal to 3. And the next step is x plus 6 is greater than or equal to 12. Well, that appears to me that they ended up multiplying this side by 4. Well, let's just talk about how we would solve this. If I were going to solve this inequality, x divided by 4 plus 6 greater than or equal to 3. If I were going to clear out my fraction very first thing, like they did, they are correct. You would multiply by 4. It would cancel out this 4, but you also have to multiply this plus 6 times 4 because it's not part of the fraction. So it also gets multiplied by 4. So you're still left with your x left from the fraction, but you still have to do 4 times 6 becomes 24. Greater than or equal to, and 3 times 4 is 12. So their mistake happened here. They forgot to multiply the 6 by 4. Another way that you could have done this, instead of going straight to multiplying by 4, you could subtract the 6 first and then multiply by 4. So that could be another way to approach this problem, but the mistake that they made is that when they multiplied by 4, they forgot to also multiply the 6 by 4. So when we've corrected the problem, let's go ahead and finish solving. If I want to get x by itself, I'm now going to subtract 24 from both sides. So I have x is greater than or equal to negative 12, and there's my solution. So now let's deal with a few word problems just to get this out of the way. So number 11 on your notes is about Carl's Cable Company. So Carl's Cable Company charges $55 for monthly service plus $4 for each on-demand movie. Teleview Cable charges $110 per month with no fee for on-demand movies. For what number of movies is the cost of Carl's Cable Company less than the cost of Teleview? Well, let's write an expression for Carl's Cable first. It's $55 a month, and we're going to assume that it's for 1 month, okay, plus $4 for each on-demand movie. And we want Carl's Cable to be less than, so it's going to be less than Teleview, which is $110 per month with no fee for on-demand movies. And so it's just, we're going to say it's for 1 month, so we don't have to worry about an extra variable going on or anything. So we got to figure out how many movies it's going to take for the Carl's to be less than Teleview. So here's what we have to do. We've got to solve for x, so we're going to subtract 55 from both sides. And so we end up with 4x is less than 55. And then we're going to divide both sides by 4. And when we divide both sides by 4, we get x is less than 13.75. Problem is, x stands for the number of on-demand movies. And I don't know about you, but even if you watch 3/4 of the movie, they're still going to charge you for the whole movie. So when we're talking about how many movies can you watch, for it to be less than, then we have to round it to the nearest whole number. And so our solution really should be x is less than 14 movies. And so the number of movies that can be watched so that Carl's is less is anything less than 14 movies. If you watch 13 movies, if you watch 10 movies, if you watch 8 movies, anything less than 14 movies will make Carl's cable less than the cost of Teleview. So it takes 14 movies for it to be more expensive. Okay, so number 12, a candidate for class president receives 57 votes, which is at least 30% of the total number of votes. We have to write and solve an inequality that represents the numbers of students who cast votes. So we know that there were 57 votes. 57 votes is at least 30% of the total number. So the 57 votes is at least, which means that's the least it can be. So it's greater than or equal to, remember 30% is 0.3 or 0.30, the total number of votes. So we got to figure out how many students cast votes. So we got to get x by itself. We're going to divide both sides by 0.30. And when we do that, we get that 190 is greater than or equal to x. And so like the one that we did a few minutes ago with the 11/3, that's written backwards. It's not because the x is on the right. It's easier to read if x is on the left. So I'm going to rewrite it. X is less than or equal to 190. So the number of students who cast votes was 190 students or fewer. So anything 190 or smaller is how many students ended up casting votes. So one last one here. This is an average question. Sorry, I was going to change my pen and then I didn't. So a runner's time in minutes in 4 races are 25.5, 24.3, 24.8, and 23.5. The runner's going to run at least one more race and wants to have an average time at less than 24 minutes. So we got to have an inequality to figure out how many minutes it's going to take to achieve the goal. So it's an average, which means we start by adding up what we know. So that's the first thing I'm going to do. I'm going to add up those numbers. 25.5 plus 24.3 plus 24.8 plus 23.5. And so far he has run for 98.1 minutes. Plus he's going to run an extra race. That is a total of 1, 2, 3, 4. The extra is 5 races, so I have to divide by 5. And he wants his time to be less than 24 minutes. So here is our inequality. Now we have to solve it. So we're going to multiply both sides by 5 so that I can cancel these out. So I have 98.1 plus x is equal to, it is not equal to, it is less than, I keep wanting to write my equal signs, 120. And so to get x by itself, I will subtract 98.1 from both sides. And so I end up with x is a number less than 21.9. So in order to achieve his goal, this runner will have to run his next race in less than 21.9 minutes. And so 21.8 or less. Okay, so 21.9 doesn't work because it's not or equal to. It has to be less than 21.9. So he's really going to have to train hard and up his game because 21.9 seconds that's shaving off a lot of time. So anyway, those are inequalities. We will practice these when you guys come to class tomorrow, and I will see you then.